Quadratic models. So real life problems. Example 1 says Jenny wishes to fence off a rectangular garden in her backyard. She has 20 metres of fencing wire which she uses to fence 3 sides of the garden with the existing timber fence forming the other side. Calculate the maximum area she can enclose. So I'm going to draw myself a little picture. It's always good to draw yourself a little picture. So here we have a rectangle. She's doing a rectangle, but one side of the rectangle has already got a fence. So we'll call these x. So to get the width, we've got 20 metres of wire, but we've got to take away x for the length and divide by 2. So our width becomes 10 minus x divided by 2. That's great. Now, we've got an area. It's talking about an area. So the area equals length times width. Our length is x. Our width is 10 minus x divided by 2. So we get 10x minus x squared over 2. Now, we've got to complete the square so we can work this out. So I'll just write this down. Now, with completing the square, we've got to take out negative a half from in front of the x squared. And I'll put square brackets around this because it becomes x squared minus 20x. Half of the 20, negative 20 is negative 10. Square root is 100, so plus 100 in here, minus 100, and close off my square brackets. So I get negative a half, x minus 10 all squared, minus 100, and bringing in that negative a half gives me negative a half, x minus 10 all squared plus the 50. So the maximum area occurs is 50 meters squared at x equals 10, because that's the turning point of it. Example 2. It's looking at a cricket ball is thrown by a fielder. It leaves his hand 2 meters above the ground and is caught by the wicketkeeper 60 meters away at a height of 2 meters. After the ball travelled 25 meters, it was 15 meters above the ground. The ball travelled in a parabolic path, so it tells us it's a parabola with the equation y equals ax squared plus bx plus c. Find the values of a, b, and c. So let's draw this on a axis. So we've got y here. It starts at 2 meters above the ground. It travels at a parabolic path, gets thrown, stops there, 60 and 2. This is my x point. Another point, they give us 15 meters, and it is 25 meters, and it's 15 meters above the ground. So we've got that one there as well. So we've got y equals ax squared plus bx plus c. But I know my c equals 2. So I get y equals ax squared plus bx plus 2, which is great. So I'll continue it over here. I've got 2 points, 25 and 15, so I'll look at 25 and 15. 25 and 15, I get 15 equals a 25 squared plus b 25 plus my 2, and 60 and 2 gives me 2 equals a 60 squared plus b 60 plus 2. Now simplifying the first one, I will get 625a plus 25b equals 13. There's my number 1. The other one, 3600a plus my 60b equals 0. Divide all this by 60, so I'll get 60a plus b equals 0. That's not an issue. It doesn't matter how you do it. I'm going to times this by 25. So I'll call this 2, call this 3. Times it by 25 gives me 1500a plus 25b equals 0. That's my number 4. So I'm going to work with 1 and 4. I'm going to go number 4, take away my number 1. 1500 minus 625 gives me 875a equals negative 13. So a equals negative 13 divided by 875. And I'm going to substitute that. A equals negative 875 in Doesn't matter which equation. I'm going to do equation number 3. That's supposed to be the word in. So I get 60 times minus 13 over 875 plus b equals 0. And when I solve for b, I get 156 divided by 175. So therefore, I found my rule. I've got y equals negative 13 over 875 x squared plus 156 over 175 x plus my 2. Part B says find the maximum height of the ball above ground, and C, find the height of the ball 5 metres horizontally before it hits the wicket-keeper's hand. So for the maximum height, remember we want to go between the x values. That's what my x part will be of the height. Now, halfway between x values, which are 0 and 60, is 30. So the x part is 30. And substituting that in, I get y equals negative 13 over 875, 30 squared, plus 156 over 175. Now I'm going to do this on the calculator. I'm not going to do this freehand. Plus my 2 equals 538 divided by 35. Therefore, maximum height is 538 divided by 35 metres at x equals 30 metres. So that's my part B. My part C, I'll do over here. Find the height of the ball 5 metres horizontally before it hits the wicket-keeper's hand. Now the wicket-keeper, remember, is 60 metres away. So 60 metres minus 5, we're looking at x equals 55. So when x equals 55 metres. We substitute that in, we get y equals negative 13 over 875. 55 squared, again I'm going to do this on the calculator, 156 over 175, 55 plus my 2, and I get y equals 213 divided by 35 metres. So height when x equals 55 metres is 213 divided by 35 metres. And that's your 4M questions.